Welcome to the Explainer. Today, we are diving deep into the real engine room of Databricks, compute clusters. You know, they're the power behind every single query and every model you run. But here's the thing. Getting them wrong can silently and very quickly drain your budget while slowing down your most important work. We're going to show you how to get them right so you can max out both your performance and your savings. So let's just kick things off with the core problem, which honestly, this slide just lays out perfectly. Databricks is an unbelievably powerful platform, but all that power, it comes with a price tag. And as you can see, a lot of teams end up overspending by a huge margin. We're talking 30 to 50%. And it's not because the platform is bad. It's just because of inefficient clusters and workloads that haven't been tuned. That is a ton of money just left on the table. But hey, don't worry. We've got a roadmap to turn all that confusion into confidence. We're going to start with the basics, what is a cluster? Then we'll explore your options for different kinds of jobs, talk about the super high-speed Photon engine, and wrap it all up with some real actionable strategies you can use to get your spending under control. Okay, let's get into it. Before you can optimize something, you got to understand how it's built, right? So, what in the world is a Databricks cluster and how does it all fit together? At its simplest, just think of a cluster as the engine that runs all of your code. Doesn't matter if it's SQL, Python, or R, the cluster is the group of virtual machines that actually executes that code against the data in your lakehouse. It's the thing that does the work. Now, what's really cool is this brain versus muscle analogy on the slide here. Every single cluster has one driver node. That's the brain. It acts like a project manager. It looks at your code, figures out a plan of attack, and then starts handing out tasks. And then you've got the worker nodes. That's the muscle. They're the team that actually gets those assignments and does all the heavy lifting. So this structure gives you two basic moves when you need more power. You can scale vertically, which is kind of like giving your existing workers a supercharge, making each machine bigger and more powerful. Or you can scale horizontally, which is like hiring more workers for the team to spread the load. Getting this difference is absolutely key to sizing your clusters the right way. All right, so now that we've got the basic structure down, let's look at the different types of engines Databricks actually offers. Because this is not a one-size-fits-all deal. Picking the right compute for the job is really your first big step toward getting those costs optimized. And this slide, it pretty much lays out the golden rule. If you're doing interactive work, like messing around in a notebook, you use all-purpose compute. For your scheduled, automated pipelines, you use job compute. And for your BI dashboards and SQL queries, you use SQL warehouses. Now look at that last row. The key difference is the DBU rate. DBU, that's a Databricks unit. It's basically how they measure processing power. A lower rate means a lower cost. Seriously, using job compute for your automated stuff is one of the easiest money-saving tricks in the book. And then, on top of all that, you've got serverless compute. This pretty much takes all the infrastructure management headaches off your plate entirely. Databricks just handles it. And this is a total game changer, especially for BI workloads, because you get almost instant startup times, and it scales down super aggressively. So you truly only pay for the queries you're running, right when you're running them. Okay, now let's talk about strapping a turbocharger onto that compute engine we've been discussing. This is where Photon comes in. And believe me, it can totally change the game for both your performance and your costs. So Photon is Databricks' own high-performance query engine. Instead of processing data one row at a time like traditional Spark, it uses this thing called vectorized execution. Basically, it processes data in huge batches, and that makes it incredibly efficient. The result? Well, as you can see here, you can get massive performance gains. We're talking up to 12 times faster in some cases. With a speed up like that, the obvious question is, why wouldn't you just flip the switch and use it for everything, right? Well, it's not quite that simple. See, here's the catch. That incredible speed, it comes at a higher DBU, that Databricks unit cost we talked about. So it becomes a strategic trade-off. As this table shows, for big ETL jobs or queries that are scanning tons of data, Photon is a no-brainer. The performance boost saves so much time that it more than pays for itself. But for small, quick jobs, you might end up paying more for a speed up you don't even notice. And this brings us full circle, right back to solving that problem we started with. Now that we understand all the building blocks, let's put it all together. Here's your practical checklist for mastering cost optimization. First things first, you have to match your hardware to your workload. Cloud providers have different families of virtual machines, each one tuned for a specific task. You wouldn't use a race car to haul furniture, right? It's the same idea. If you're doing ML, you want memory optimized. For streaming, go with compute optimized. And the most important one to get right, don't even think about using those expensive GPU instances unless your code is specifically written to use them for something like deep learning. Using the wrong one is literally just burning money. Next up, you can get really clever with a hybrid strategy. Spot instances are an amazing way to save cash. You're basically using spare cloud capacity at a huge discount. The only catch is they can be taken away with very little warning. So the best practice, the pro move, is to use a stable, more expensive on-demand instance for your critical driver node, the brain, and then use those cheaper spot instances for all your worker nodes, the muscle. And that brings us to what might be the most important takeaway of this whole thing. If you do nothing else, please do these 3 things. 1, enable autoscaling. Let your cluster grow and shrink automatically so you only pay for what you use. 2, set an aggressive auto-termination policy on your interactive clusters. If nobody's using it for, say, 30 minutes, shut it down. And 3, use spot instances for your worker nodes whenever you can. These 3 simple actions will have the biggest impact on your bill, period. And that's really the final thought I want to leave you with. Look. Your data is going to grow. Your ambitions are going to grow. You don't want your costs to just grow right along with them. By applying these principles, picking the right compute, using Photon strategically, and optimizing your configurations, you can make sure your clusters grow smarter and more efficient, not just bigger and more expensive.